Hello everyone, this is going to be kind of weird because I'm doing a voiceover, so the writing's not going to match my voice. But in 4.2, we were going to talk about isosceles and equilateral triangles. Just knowing that isosceles, fancy word for triangle with two congruent sides. We call those the legs. Your two legs intersect at an angle in the triangle, and in that picture, they intersect at angle C. Angle C, fancy name, vertex angle. The side that is opposite the vertex angle, so the one that is not congruent to the other two sides, we call that just the base. B-A-S-E. I know you guys have heard that phrasing before with a triangle, just knowing that the base this time is the side that is not congruent to the other two. The angles along the base, so in that picture it is angle A and angle B, those are called our base angles. And we're going to complete the theorem below, but knowing when we have two congruent sides is going to tell us that our base angles are also congruent to each other. So sorry, I'm just filling that in at the moment. But now we're going down to the isosceles triangle theorem. If you have two congruent sides, then the angles opposite those sides are congruent. They're just talking about the base angles. If your two legs are congruent, so are your base angles. Converse just means that you take a statement and you flip the if and then. So if two angles are congruent, so are two sides. So they're just writing down right now that if you have two base angles that are congruent, so are the two legs. Down here, we have a weird theorem called the isosceles triangle bisector theorem. If a segment bisects the vertex angle, so angle A is being bisected, we got to remember that bisect means to cut in half. So they're taking that angle A, or we can give it three letters saying like CAB. Now we have two congruent angles. But that same segment is also a perpendicular bisector, which we briefly talked about in Unit 2. But a perpendicular bisector is going to cross at a 90-degree angle and also cut that base into two equal pieces. So not only is AD perpendicular to BC, but CD and DB or BD are also congruent to each other in length. This is just a little trick, right? You're not going to see every single problem be like this, but it at least helps us to know that when we have this going on, there's some good tricks. Number 1 through 3, they want you to find the measure of each angle. Look at what they gave you. They give you two congruent sides, which we can now say means that we have two congruent angles. Vertex angle is not congruent to the other two. So this is just me labeling the vertex angle to show that angles 2 and 68 will be the congruent ones. Those are your base angles. So angle 2, also 68. Okay, how we find 1 is just knowing that all the angles have to add up to 180. So the measure of angle 1 plus the measure of angle 2, which now we know is 68, plus another 68 is equal to 180. And now we can go and just solve this equation. Let's combine like terms. 68 plus 68 is going to give you 136, if I'm correct. Just making sure. There it is. Okay, 136. That is equal to 180. But then let's subtract 136 from 180. You get 44, and there is your angle 1. You can always just check, right, to make sure that they add to 180. In number 2, they also give you two congruent sides, right? So find vertex angle. That angle is not going to be equal to the other two. So 122, it's on its own little land right now. Angles 1 and angle 2 are going to be congruent to each other. Okay, just remember all the angles have to add to 180 degrees. So 122 plus angle 1 plus angle 2 is going to equal 180. Subtract the 122 off, right? Let's just say that angle 1 plus angle 2 is going to be whatever 180 minus 122 is. If you're doing that math in your head or with a calculator, you're going to get that it's 58. Okay? But we know just from isosceles triangles that angle 1 and 2 have to be congruent. So let's cut that 58 in half and give that value to each of 1 and 2. So to both of them. So half of 58, you get 29. So angles 1 and angle 2 have to be 29. Number 3. So this time, they don't give you two congruent sides, but they do give you two congruent angles, right? Those are your base angles. So we already know that two congruent sides gives you two congruent angles. Now let's use the converse. Both of those legs are going to be 14 inches. So I'm just writing that down now, right? 14 inches. But angle N, right, the vertex in this picture, just use your knowledge, right? Triangle sum, all the angles add to 180. So let's set up an equation. Angle N plus 44 plus another 44 is going to equal 180. Well, 44 plus 44 is 88. Add that by angle N, that is equal to 180. And now let's take away 88 from 180. I will say I make a mistake here. I believe I put 96, but that is not right. All right, 180 minus 88 does give you 94. So there we go. Angle N is 94 and VN is 14. Alrighty, here's number 4 on the second page. In triangle RST, segment RT and segment ST are congruent to each other. So two sides of the triangle, they're equal. So we could say that this is isosceles. Vertex is where those two legs intersect, right? So angle T in this case, which means R and S are congruent. Isosceles triangle. Now let's fill in the rest of the information, right? They give you the measures of each angle in terms of x. So angle R is 9x plus 2. Angle S is 13x minus 18. And angle T is 17x plus 1. Okay, wait. They're giving you information about all three angles. What do all three angles of a triangle have to add up to? They got to add up to 180 degrees. Okay, so this is me saying, here's one way to do this problem, right? 17x plus 1 plus 13x minus 18 plus 9x plus 2, all those angles have to add up to 180, right? This is just one way to do this problem. I'm putting parentheses to separate that these are three different values, three different angles. Let's combine like terms, right? 17x plus 13x plus 9x is going to get you 39x's. And then the numbers, right, are constants. 1 minus 18 plus 2, we should get that that is negative 15. That is equal to 180. We will solve that in just a second. Way number 2 is just using the information about isosceles triangles that we know, right? What are equal in these triangles? We have congruent sides and we have congruent angles, right? So set the base angles equal to each other. Whenever we give you base angles, they're always going to be equal in that isosceles triangle. So that's just way 2. All right, set the base angles equal. And now you have two different equations. These two different equations are going to get you the same exact answer, right? And this is me just showing you and proving it. Add 15 to both sides for the first one. You get 39x equals 115. Divide both sides by 39, and you're going to get that x is equal to 5. I'm just typing into a calculator at that point. But yeah, you do get 5. Equation number 2. Maybe work smarter, not harder, right? You don't have to show all the work to this equation. But if you get the x's to the right side, I believe I show it. Yeah, that's going to get you 2 equals 4x. Hold up, phone. There we go. Minus 18. And then we add 18. We'll get that 20 is equal to 4x. And then if we divide both sides by 4, then we get 5. So same answer as the first equation. Now they want you to find the measures of each angle, right? Now we just plug in. Now we're just going to plug in 5 for x. So angle R is going to be 9 times 5 plus 2. Angle S is 13 times 5 minus 18. And angle T is going to be 17 times 5 plus 1. Right, just going back to what was given to us in the instructions and plugging in our now found x. This is just me simplifying, right? 9 times 5 is 45, plus 2 is 47. 13 times 5 is 65, minus 18 is also 47, right? Base angles congruent, those got to be the same. And then 17 times 5 plus 1, you do get 86. And if you add those all together, you do get 180. So that is right. In number 5, triangle DEF, angle D is congruent to angle E. So this time we're given 2 angles congruent. Those are our base angles. That means we have 2 congruent sides. There's me putting that down, right? DF and EF will be congruent. So those are our legs. And now let's just fill in the rest of the diagram. DE is x plus 4. EF is 4x minus 8. And DF is 7x minus 35. Find the value of x. When we're trying to set up an equation, what we need to do is find 2 things that are equal, or knowing that angles add up to 180, right? And in that picture, we have tick marks on 2 of the sides. DF and EF have to be equal, right? They're the legs of our isosceles triangle. So set them equal, solve for x. Subtract 4x to both sides. We're just getting the x's to the same side. 3x minus 35 equals negative 8. If we add 35 to both sides, we are going to get that 3x is equal to, doing the calculation, you get 27. It's just me doing the calculation. And then dividing by 3, x is equal to 9. Okay, and what we do to find what each of those sides are is just plug them in, right? Plug 9 in for x. So 7 times 9, take away 35. 4 times 9 minus 8. And 9 plus 4. Okay, and when we substitute everything in, we are going to get that x is equal to 9, obviously. DE is 13. EF is going to be 28. DF will be the same thing, right? They're both congruent to each other. Number 6, in triangle ABC, if AC is congruent to AB, those are our legs of our isosceles triangle. So find where they intersect, right? A, in this case, is going to be our vertex angle. They want you to find the value of x and y. And notice that x and y are inside angle measures. So we're going to be using all our knowledge about angles for this problem. A is 14x plus 6. Angle B is 2y. And angle C is 52. Okay, well, isosceles triangle. Base angles are congruent. So let's set up the equation of 2y equals 52. Solve for y. Divide both sides by 2. We're going to get that y is 26 degrees. Half the problem's already done for us. But to find x, we do have to know that base angles are congruent. So angle B is also just 52 degrees. But triangle sum theorem. 52 plus 52 plus 14x plus 6 has to equal 180 degrees. Alrighty, let's go and solve for x. So combine like terms. 52 plus 52 plus 6. That will get you 110 degrees. So 14x plus 110 is going to equal 180. Subtract the 110 to both sides. 14x is going to be equal to 70. And now we can divide both sides by 14. We'll get that x is equal to 5 again, right? Another problem where x is 5. But now we know that x is 5 and y is 26. Let's go to example number 7. Triangle JKL. JK, KL, they're telling you they're congruent. So looking at that entire triangle, it is isosceles, right? Two congruent sides. KM is bisecting JKL. K is the middle letter, so we are going to look at that angle. It is bisecting, right? It's cutting in half. Two equal angles. That's why I put those little arches. That segment is also acting as a perpendicular bisector, though. So crossing at a right angle with the base and cutting the base in half. JM and ML are also equal. This is just me reinforcing that we do have base angles congruent. I'm using a different number of tick marks to show that those angles are equal. Right? Matching number of tick marks. JKM, middle letter, right? K. So looking at angle K, which side is pointing towards J and M? It is the left side. JL is 42. So notice that there's no degree symbol, right? That is a side length here. And then lastly, they do tell you that JM is 6x minus 3. But we did just discuss that the base is being cut in half by KM. So 6x minus 3 can go on the other side for ML. And that's where our first equation is going to come from, right? They want you to solve for x. 2 copies of 6x minus 3 is going to equal 42. This is that segment addition postulate all the way back from Unit 1. So that doesn't go away. Add like terms, you get 12x, you get negative 6, still equal to 42. And just look at the screen to follow the rest of the equation. Adding by 6 and dividing by 12, and you'll get that x is equal to 4. Alrighty, so these angles all have 3 letters in them. The most important one, though, is always going to be that middle letter. The middle letter tells you where the angle is forming. So for example, if we're trying to find angle JKL, they want you to just find that very top angle. Well, we already know that half of it is 40, so we can say that the other half is going to be 40. Add them together, JKL in its entirety is going to be equal to 80 degrees. M is the middle letter for the second one, but notice that both angles at M are right angles. So KML is a 90-degree angle. KLM, L's in the middle, so go to the right side. KJM, J in the middle, J's on the left side. Those are your base angles, so these are just going to end up being congruent to each other. So whatever one is, we know the other one's going to be the same. Well, JKL, remember, all the angles add to 180. So this is just me showing that J plus L plus K equals 180. Subtract 80 from both sides, you'll get that that's equal to 100, but then cut it in half and give each half to J and L. And you'll get that they're both equal to 50 degrees. Alrighty, last part of today's notes. Equilateral triangles. A triangle is equilateral. That just means that if a triangle has all sides that are congruent to each other, it can only happen when all your angles are congruent to each other. Or that word is called equiangular. I do have it on the screen. Okay, so this is just saying that in order to have all sides congruent, all angles also have to be congruent. So take a look at the picture, right? I'm annotating right now. 3 congruent angles and 3 congruent sides. Look at all those tick marks. Alrighty, filling in those 2 last lines, I do have a mistake on there. There's AC twice on that bottom line, so just fix one of those to AB. All this is saying is that if you have 3 equal angles, you have 3 equal sides. Flip it around. If you have 3 equal sides, you got 3 equal angles. Lastly, every angle in an equilateral triangle is always just going to be 60, right? If they're all equal, take 180 and cut it into equal thirds, and you'll get 60 degrees. So For now on, equilateral triangles, all the angles are 60. Alrighty, so number 8, notice that they give you two angles that are 60, right? So triangle sum just says that all of them have to be 180. Angle C has to be 60. Okay, so knowing that all three of these angles are 60, now we could say that we have an equilateral triangle, right? So tick marks and arches on every single picture. There we go. Now we can just see that AB and BC, those other two missing sides, have to also be 16 feet. Number 9, this time they are telling you that it is equilateral by giving you three congruent sides. But notice they don't want you to use the 10. They just want you to find the angle measures. Well, what's 180 divided by 3? 60, 60, and 60. All three angles in an equilateral triangle will always be 60 degrees. Alrighty, so number 10. Still an equilateral triangle, but this time they want you to find the value of x, right? So all three sides congruent, all three angles congruent. So 2x plus 32 is just going to be equal to 60, right? It's one of the equilateral angles. So subtract 32, you'll get that 2x equals 28. And when you divide it by 2, you'll get that x is equal to 14. All that space for just a little equation to solve for x. And last problem, number 11, they are telling you that it is an equilateral triangle. So watch me do my labelings, right? Tick marks on the sides, arches on the angles, and they want you to solve for x and y. Well, same thing as the last problem, right? That 8x minus 4 is in an angle, which means it has to be 60 degrees. So adding 4 to both sides, we're going to get that 8x equals 64. And when you divide it by 8, you'll get that x is equal to 8. The y's are in side lengths, and in equilateral triangles, all sides are the same. So what we're doing here is we're just setting the sides equal. So here's me solving for y, right? Subtract both sides by 4y. You get that y minus 6 is equal to 12. And then when you add both sides by 6, you'll get that y is equal to 18.